What I'm saying that in this assignment, the fourth is something which will be mainly covering today. And again, I'll relate whatever I've discussed so that there will be some sort of revision. So this whole assignment is based upon previous and today's discussion. Sorry. So these things are action. So if you remember my discussion in last class, we'll continue with that same OneNote file. And we have covered many things. We have discussed about risk, and then volatility, standard deviation. Then we have talked that wherever the standard deviations are there, you need to have forecast value, and then you will find Gauss models are very handy, especially Gauss 1-1 model. And then I gave you specification of Garch PQ, and I said that PQ can be estimated. Again, you can decide right P and Q on the basis of AIC or SIC decision criteria. Lower the value, better the model. That type of thing can be used. I gave you some idea where this whole thing is coming from. I told heteroscedasticity where the variance of error term is maybe constant with respect to exogenous or independent variable, but the error term variance may not be constant with respect to time. Then we have got something known as arch effect. So it's a type of heteroscedasticity. That's why the name conditional heteroscedasticity is there. And AR, because when we talked about it, then we said that we talked about the this expression was of use when I said autoregression, because this is the square of the error term, which is equivalent to variance, and that is having the autocorrelation or autoregression, its own lagged term. So variances lag term is having the significance. Then we say effect or conditional heteroscedasticity. So autoregressive term is giving the this effect. That's why the name nomenclature of arch comes into picture. So AR is coming from this logic and heteroscedasticity because the conditional variance with respect to time is not constant or may not be constant, and that's why the whole term arch comes. And I gave you some idea that this arch is basically the variance, conditional variance is explained with the help of square of error terms, lagged values of squared error terms. Then just because number of parameters to be estimated may be slightly high. So what happened that one lagged value of the conditional variance would have been introduced. And this model was the arch model is transformed into Garch, where additional term generalized comes into picture, where the in specification this term comes into picture. So some part goes to square of the error term we call arch term, and then we have got the variance lagged variance terms, and they are known as gauge term. So conditional variance at time t is equal to some lagged values of the square of the error term and some lagged values of the conditional variance itself. So this becomes gauge. And if they are both, the error is also one lag, arch term is also one lag, and the gauge term is also one lag, then we call it Garch 1-1. And I said that literature support, the empirical evidence strongly support that Garch 1-1 is a great model that can be easily used as and when you feel like having the forecast value of conditional variance. And we have also helped you to understand how to go for estimating the forecast values. And in addition to that, we also discussed alpha and beta. Alpha is the coefficient of Arch term, and beta is the coefficient of Gauss term. And we said that alpha value should be close to 0.2, beta value should be close to 0.8 in the ideal conditions. And I also said that higher the value of beta means more persistence. If we have to compare two betas and one beta is higher than the other, especially, but they should be in the range of 0.8 plus. If they are, then we'll say that the higher the value of beta is representing more persistence, means any impact there, any innovation or any shock comes, then that shock is going to persist for longer duration. So that tendency is measured or represented with the help of beta. And alpha terms are known as how much reactive the stock or the asset prices are. If alpha is higher, again, we'll say that 0.2. So if it is 0.2 or less and higher, the alpha means more responsive the stock is. So this makes sense. If it is more than 0.2, then the ideal conditions are not met. So we say that point alpha should be less than 0.2. And if higher the alpha means more responsive, means for two, let's say stock prices are there, two volatility models you have estimated, one having, let's say, 0.0 or let's say 1.18, other is having 0.15. So 0.18 stock is supposed to be more sensitive. If there is a shock happens in the a disturbance comes in, you will find that the stock having higher alpha will be more responsive to the news. It will have larger impact as compared to the stock which is having the lower alpha. So alpha is the measurement of how much reactive the stock is, or we also call it shock, or we also call it innovation. So all these terms can be interchangeably used in the case of alpha. So alpha is response, beta is responsiveness, alpha is responsiveness, and beta is the persistence. And then I gave you some idea about some stability conditions. I guess I've discussed somewhere that alpha should be positive, beta should also be positive, and alpha plus beta should also be less than 1. So these are three stability conditions. If I have not discussed, you can note it down. I think I should have discussed this somewhere. No. Okay. So these three stability conditions or that has to be met. Alpha should be positive, beta should be positive, and alpha plus beta should be less than 1. All three conditions should be met. Only then it makes sense to have any interpretation out of alpha and beta. If alpha is negative, meaningless. So beta is negative, again meaningless. So that type of things are there. One thing which I forgot to discuss in last class was that how to ensure there is a arch effect. Because I discussed that this should be the situation that square of the error term should be having significant coefficient with its own lagged term. But how to estimate that, that is something which I didn't do. So we'll do it right now so that you will understand how to understand or how to check whether the arch effect is present or not.
Sir, could you please repeat the three conditions for alpha and beta?
Alpha and beta three conditions. Let me give you exact values which are there. If I have noted, I'll share with you. Otherwise, I'll give you the exact values because there is a clear cut univariate guards. Yes. Yeah, I'll write it for you. Write down the conditions. I'm writing here. Three stability conditions. Stability conditions. Alpha should be positive but less than 1. Beta should also be having the same, and alpha plus beta should be less than 1. So these are the stability conditions. So we'll go for finding out the arch effect. So we'll use our previous example which we were using, BSC stock we had, the calculated return series, and then we estimated the Garch 1-1 model, and accordingly we did the discussion. So we can copy also, and I have one file as well ready. We can use that file as well. So this is something I have. So if I have to check for stability, I mean the arch effect, then what I need to do, I should go for estimate equation. And for right now, we are still talking about univariate volatility models. So whichever prices you are interested in finding out whether there is a arch effect or not, first of all, you should convert that prices should be converted into return. So it serves two purposes. It will make the stationarity, and study of return series makes more sense when we talk about volatility. So it serves both the purposes. So if I just write RBSC, RBSC, and here what we do, if you remember when we were doing ARIMA, then we had auto-regressive term we used to write this way, AR1. So we had only one lag of auto-regressive term, and then MA term, moving average term, which was the error term basically, so one lag of error term. So that specification need to be written. The slide, I mean the screen is clear to you, all of you?
Yes, sir.
Yes, sir.
So what we are doing when we have to test whether one series has arch effect or not. So if prices are there, then the way we would have estimated the Gauss model, we are supposed to convert that into return. The same thing we have done here. And to test the arch effect, we will have ARIMA specification of a 1-1 order, P and Q both 1-1, something similar to it. And as this comes, we need not do much. Go to view, residual diagnostic and heteroscedasticity test. If you recall the theory, I said that the arch effect is also a type of heteroscedasticity. So keeping that idea clear in your mind that we are going to test for heteroscedasticity, but a particular type of that. So as we click, if you use either advanced or the older version, you will find that this dialog box may be slightly twisted in different shape, but everything will be there. All the white test is there. White test, if you remember, we used to test head test in Stata for a normal regression model. So that was Bruce-Pagan test. So right now our job is to test for arch effect. I repeat what I have done. We have run one RIMA 1-1 specification. It is obviously integrated because we have taken the return series, which is by nature stationary. So no problem of integration. So and we have tested 1-1. We have run 1-1 RIMA 1-1 model. And once we have run the model, then we'll go for diagnostic, I mean the coefficient diagnostics, residual diagnostic, sorry, and then we'll go for heteroscedasticity test, and there we'll go for arch effect. And in this is the arch effect, and if you find that the F statistics is significant, null in this case is no, as you remember, null in the case of heteroscedasticity is also no heteroscedasticity. That is the null which we use all the time. So same here, no arch effect. And alternate, yes, there is arch effect. So we'll stick to it, and if null is rejected, if p-value is less than 0.05, which is the case here, then we'll say that null of no arch effect is rejected, and alternate of yes, there is arch effect is accepted. And once you run the test and you find that null of no arch is rejected, you're confident that your time series has arch effect, then there's no problem in straight away going for running the Gauch 1-1 or Gauch any PQ model. But this was one of the preconditions that you have to test for arch effect. Then only we discussed in theory, but in practice we didn't discuss, so it was left. So I just showed it. Is clear to everyone? Yes.
So could you please show the equation of ARIMA 1-1? It was
Ariba,
R.
I just wrote in this return series, whatever is the return series. C, I'm writing the views command. RCC stands for constant. R is the return series, whatever it is. And then you put just AR1, auto regressive 1, and then with a space, MA1. That's it.
Okay, sir.
And then once you run, then you go to view, go for residual diagnostic, then go for heteroscedasticity testing, and there you will find all the tests are there. One test will be arch, and this arch test will be tested against this hypothesis. And if null value and the p-value of the corresponding null is less than 0.05, you will say that null of no arch effect is rejected and there is arch effect. Okay.
Yes, sir.
So let's just talk something about more about volatility. What happened that when we started anyway, we were talking about time series. So we were just talking about time series, forecasting of the time series. We talked about the stationarity, and then we went for more than one time series, and we said let's talk about VAR, vector autoregressive model, and then we also had some conditions when we applied VAR that all should be I1. If time series is in hand are not I1, then you won't be able to run VAR. That was some precondition. Then we said that VAR is only for short term, and we had one more situation where you will have a mixture of I0 and I1 series. In both the cases, you won't be able to run VAR. It means you have to look for something else. So what we said that we have got something known as ARDL, autoregressive distributed lag model, ARDL. So two things were there. VAR per se was meant for short term with some conditions. So two things were required that we have to have something which is long term. So long term association can be discussed. VAR was very giving you idea about short term, and two things we discussed: variance decomposition and one was I just forget the name. So two things we discussed when we talking about variance decomposition, and that thing was that was. I'm skipping that time. No issues. So VAR was meant for short term and supporting ideas. Then it means two things were missing. When we have got some series which are I0 and I1, then what to do and what to do for the long term association. So for having a situation of mixture of I0 and I1, we said that let's go for ARDL. So we discussed how to estimate ARDL, though we didn't go in much depth, but I gave you a brief idea. And there, when we want to go for long-term association, then in VAR setup, we have got Johnson's co-integration test. So co-integration test was basically meant for ensuring whether there is any long-term association or not. Then the issue of estimation comes into picture. Then we discussed in ARDL setup, we had bounds co-integration test. In the VAR setup, where we have all the time series are even, we had Johnson's co-integration. And if co-integration with the help of in bounds different in Johnson's co-integration test, different interpretations were there. But if co-integration is there, then we would have gone for vector error correction model. And within vector error correction model, we again talked about error correction term. But all those discussion, whether it was one series or more than one series, treating all of them as endogenous in the VAR or ARDL or vector autoregressive setup, every time we were talking about price, one single, I mean the prices only. We were not talking about volatility. So what way price, whether the prices of price or say univariate, one variable was there, second variable was there, but only series were there. So within the series, what is the volatility that was never discussed, whether the series was of prices or return, but it is only the time series which was being discussed, not the volatility present in the time series which was discussed. So by the time we would have finished off with these things, univariate discussion and VAR and co-integration and all, then we came to the idea of talking about the volatility. So by the time we start talking about volatility, it's not that we are removing the idea about the time series. We are still talking about a series Y. But what we are saying, let's talk about the volatility in Y also. Means how the values are changing. What is the speed of change? If I use very oversimplified statement. So volatility, we discussed that volatility in any time series can be estimated with the help of standard deviation, sigma. We said square root or square of it can also be one of the estimates to talk about the volatility variance. And then we gradually come to the idea about gauge specification. And once we started talking about Gauge specification, we believed and we tested right now also that there are Gauge effect, means the error term, the variance of error, conditional variance of the error term may not be constant with respect to time. And if that is happening, then we find that we have got arch effect present in the time series. So arch effect is there in the time series. So if you want to study the volatility of that time series, then you have to obviously go for Gauge type of estimation. So we studied Gauge. So Gauge was an additional part of the time series. Time series is all the way there, still there. Time series is there. But what is the volatility of time series that is being captured if there is presence of arch effect? If there is no arch effect, then there is no Gauge term. I hope my point is clear. You're getting me. That still we are not ruling out completely removing the time series. Time series will give you idea about volatility. So volatility is one of the features, like we say heteroscedasticity, autocorrelation. Similarly, we are saying that we want to know the volatility present in the time series. So that volatility, if arch term is there, we can study with the help of Gauge term. All of you are with me. I want some, discussion on that. If you are, I don't know whether all of you are absolutely clear with this. I'm waiting.
Yes, sir.
Other than Tanay, nobody is active today. What happened? One or two. Shivardhan is quite silent today. Shivardhan, are you there or preparing the assignment? Shriwardhan. So coming back to discussion on volatility. Now I'm adding one more feature or one more aspect when we talk about volatility. We said that we have a time series T, YT, and volatility of that, volatility of this time series of YT can be estimated with the help of Gauge family of models. Okay, we have discussed E-Gauge or not?
No, sir, not yet.
So I have
No,
to
sir.
discuss E-Gauge also, correct. So volatility of Gauge, volatility of YT can be estimated with the help of Gauge family of models. We have again missing out one more part, very important part of Gauge model. Uh, then we'll come to this discussion again. So when I say Gauge family, if you remember, I one point of time, maybe last class, we were talking about that a time series has got three special features: volatility,
My
clustering.
mic was not working. I wrote in the message also.
What happened?
So my mic was not working. This is Srivardhan here. I wrote in the text also.
No problem, Shivardhan. Now your mic is working, I guess. Huh?
Yes, sir.
Good, great. No problem, Shivardhan. It's okay. So I said that there are three important features of any time series which differentiate time series from any other thing. We say that in time series there is a volatility clustering. I have shown to you the clusters were there when I showed the graph, and then we said that fat tails were there. So they are not the mesocurtic but leptocurtic. And third thing we said that asymmetry. And asymmetry means the movement of a rise is usually slow as compared to the fall. When the prices plummet, they plummet very fast, they move very fast. But when they are rising, they rise very slow. So this asymmetry cannot be captured. So these two can be captured partly by Gauge specification, but asymmetry is not captured by Gauge term. So we have got something known as E-Gauge. So E gauge is something which we have to run, and there is something known as gamma. I'll show you as I run. So we look at the significance of gamma. Gamma again, null is gamma is equal to 0, and else alternate gamma is not equal to 0. If gamma is significant, means it is non-zero, then we'll say there is. This is also known as leverage effect. This term I would have discussed. So we'll look for gamma. And as the value of gamma is significant, we'll say that the leverage effect is significant. So leverage effect will be decided with the help of running the E-Gauge model, and within E-Gauge we'll look for gamma. And if gamma is significant, then it means it signifies that the model is having leverage effect. So I'll show you the equation also. I guess I have the equation which I thought I'll share. Because as we run, we need to have a specification. It would be slightly difficult to look for where that gamma is. So this is Gauge PQ specification. I hope it is visible to all of you.
Yes, sir.
So look at, this is the error term, and this is conditional lag of error term and conditional variance, lag of conditional variance. So there is a corresponding. You'll find similar term is there, but this is absolute. So this is not giving you gamma, but this is giving you gamma. So we'll look for this term, because what happened, E-Gauge specification was given by Nelson and all, but what happened when we actually run or we apply, then slight modifications are permitted and given by freedom given by Nelson. So the original equation and this equation I have intentionally copied because this is the output which comes in eViews. So just because we are going to run it on eViews, so it is better to follow the specification of eViews. But original specification of eGauge may be slightly different than this. So if you happen to come across eGauge specification or the expression which look like differently, in reality everything is going to be same if it is eGauge. So you should not be concerned or worried. The only explanation is that different software might tweak according to their own comfort levels. So there's nothing wrong in having this specification of eGauge model. So here I'll run it. I can go for estimating straight away. So let me close it so that you don't confuse. So I have to run for eGauge. So I'll go for RBSC C, and I said that we'll take the one autoregressive term. So RBSC minus 1. This is the equation which we write in for series. If you look at, this is the series specification, and we'll go for arch term. So this remains there. This we are not changing, and this is not the variance specification. Variance specification will be given here, and we want some additional variance regressors or exogenous variable. We can provide that. We are not touching those areas. And options we usually go for making the eViews legacy. So the starting terms follow the thing. Arch term, gauge term, and we have to have, but here T-gauge we are not estimating. T-gauge is also meant for asymmetry, but we'll go for E-gauge. So asymmetry order is coming one. So it is not the threshold order, it is asymmetry order. T-gauge will give you, for the same purpose of asymmetry, we have got two models, E-gauge and T-gauge. As we usually say, gauge family of models, a very big family. We are touching upon only those areas which are meaningful and relevant and gives you some conceptual clarity. So as you become expert or you want to be very good at those things, then you will obviously understand the whole thing as you start using it quite often. So at this juncture, these many items are enough: gauge and E-gauge. Gauge for normal situation, E-gauge for capturing the asymmetry. So we'll go for OK. So as we go for OK, here you can find out, you might have to struggle a little bit. There is a term C4 which is with the absolute. I can probably go for view representation will give you some detailed expression, and there probably you may be able to look at the coefficient clearly. C4 is with this, so that you can avoid reset minus 1 and square root of this dot. So if you remember, I have shown you this. So when I'm sigma, so sigma, it is the sigma square is the variance, so it is sigma only. So square root of sigma. So this term, as you're finding, the reset minus 1. So look at this error minus, 1 lakh term. Reset minus 1 is nothing but the error term with 1 lakh. After all, we are talking about 1, 1. And this square root of Gauss term means square root of conditional variance, which will be standard deviation, and with 1 error term. So what we are understanding, gamma is C5. This is clear, this discussion, because this is important to look at the expression Gauss, E-Gauss expression. And in E-Gauss, we are looking for this gamma for ensuring whether there is a significant leverage effect or asymmetry there or not. Means movement of plus and minus, rise and fall are symmetrical or asymmetrical. So if gamma is significant, then we'll say that it is asymmetrical. So what is gamma? As we are seeing it here, the coefficient attached with this term, and this is what we have estimated. From here, you go to view representations. So representations will give you the expression. So this is the expression, estimated equation. And what you are finding here, this C4 is a misleading term because it is within the absolute. So within here, so this may be the C4, but we are not interested. We need gamma. So gamma is nothing but C5 because it is having the lag of error term and lag of the sigma term. So C5 is the gamma term. I hope gamma is clearly visible. No, then I only will unmute and say yes, sir. What about others? Where is
So
Akash
please
Ashok
show the
Gupta?
C5 one.
Srivardhan, please tell me again.
So please show the C5 term once again.
This is I can't. So this is C5.
Okay, sir. Thank you.
Where is Mr. Akash Gupta? Akash Gupta. Is he there?
Yes, sir.
So Akash, you are listening. Great. So Akash, C5 is clear. Srivardhan helped you again to have a relook on C5. C5 is gamma. Yes?
Yes, sir. Yes.
So the next issue is obviously we'll look for C5, whether it is significant or not. So C5 is here and C5 p-value is here. And as p-value is less than 0.05, we will say that the C5 term is significant. So we'll say that in the case of BSc with the given time series data with the given sample size, what we are finding that the leverage effect or asymmetry is significant. So this is the basic idea. So if there is asymmetry, obviously, if there is asymmetry, then it is also preferred that you go for EGARDs. But surprisingly, when it comes to forecasting or using the conditional variance term from different models, though it is there, the leverage effect term may be significant, it has been found that GARCH 11, which is also known as plain vanilla conditional volatility model, is supposed to be better. So people quite often do not bother when they want some fine-tuned discussion. They obviously go for all those things and check whether leverage effect is there or not, asymmetry and issues, all those issues are discussed. But when it comes to estimating, they quite often use GARCH 11 and go ahead. So you will get a lot of literature also which supports. When I say literature supports, like vaccines, COVID vaccines are coming. So how do you know that something is effective? They also cite something that earlier studies have said this. So that's why on the basis of their finding, we can say that this medicine is effective. So you need to understand the basic mechanism of research is common, same across the board. Wherever you apply research, you will find same thing is happening. So when I put forth this logic that there are a good number of literature support to use GACH11 even when there is significant leverage effect. So I make sense. I'm citing some earlier established research work to take my work ahead or to tell to you that this can be done. So despite the fact of significant leverage effect, GACH11 really works very good. It can be applied. But you want to be fine tuned and you are insisting that you would like to use EGACH, use if you find that gamma is significant. I think so far I have not missed out anything on univariate GACH, and now I can talk about bivariate thing. So as I was talking about before this, here I was somewhere here. Okay, I'll start again. So I was saying YT, and to study the volatility, we can go for estimating GARCH. Family of models, I insist, family of models. So I'm not saying that only GARCH is the best model, others can be. So, but what is the basic idea when I'm saying this? That we are using only one YT, or to be more precise, Y1T. But can you rule out that there will not be anything else, let's say Y2T or nothing like Y3, which will not be impacting, which might not be, or which will not at all impact the volatility of YT? If suppose this is the variable where we are all are interested and we don't want to deviate from this, perfectly all right. But question is, when we are saying that these GACH family of models, we are assuming that whatever is the volatility present there, that is something what we are estimating. But what we are saying, the impact on the volatility of this can be from other variables. Source of change of volatility on this can be other variables. And if we can capture both, it's not that we are ruling out the estimation of volatility from Y1T. So volatility of Y1 will be there, but the impact of volatility of Y2 will also be there. So it is some sort of combination. So when I say sigma 1 square, I'm saying that when I'm studying the total sigma on 1, then that will be this, I'm saying this due to Y1, and then there will be or just put it due to Y2 or due to Y3. So this total will give me better idea. So Y1 impact, Y2 impact, and Y3 impact, and we are studying the volatility or conditional variance of Y1. So this is something, this is the idea when we say that let's talk about bivariate or multivariate. Multivariate GACH. So GACH is again a name for using the conditional heteroscedasticity, that too in the autoregressive format using generalized format. So GACH is just a name. It's not that GACH11 we are referring to. So bivariate or multivariate GACH family of models can also be used when we believe that the conditional variance or volatility of one not only going to be impacted by its own volatility, but volatility of other time series or variables can also impact this. So this is a typical situation of using bivariate or multivariate. But what happened as we move from univariate to bivariate? We believe that when we want to know the volatility of Y1, and we are saying that the impact is due to Y1 and due to Y2, due to Y3. So what we are saying that the number of terms, because if you look at terms, Y1 is equal to, already we are having let's say we talk about omega 1 plus alpha 1 and error term 1 t minus 1 square plus beta 1 and sigma 1 t minus 1 t is assumed here square. So I'm ignoring the error term right now. So how many coefficients we are talking about? 1, 2, and 3. And as we have got 3, then think that how many combinations we are going to add. Because every time we have to talk about a situation where error term 1t with 2t, then 1t with 3t. I mean, so y1, y2, y1, y3. So all these terms are going to be, I'm saying when I'm using y1, y2, so I'm saying error term and conditional variance term. So y12, y13, y23 is also there. So it will have their error terms, it will have their conditional variance lag terms, lagged error terms. So what happens when we talk about bivariate or multivariate volatility models? The biggest problem which people come across while when they want to estimate is number of parameters. Number of parameters or coefficients to be estimated. And when we have too many parameters to estimate, probability of error and discomfort also goes high in that proportion. So it is really great to have bivariate or multivariate models to study the volatility of one with respect to not only itself, but due to other variables. But when it comes to actually estimating it, then it becomes very difficult. I'll tell you that around I wrote a paper on volatility spillover effect of US and Indian stock market somewhere in 2020, and the journal was IMT Ghaziabad's journal. I wrote the paper, but that time when I was trying to find out or try to run bivariate gauge, the computing the facilities which were available were very limited. Means I could have manually made the model, but when it comes to taking help from software in eViews, I remember those days. Right now we are using eViews 11. Those days it was eViews 4 or 5. So that was not helpful in estimating the bivariate Gauss model. But right now I can. It is possible, though still there are a lot of limitations even in eViews and Stata to estimate the bivariate or multivariate Gauss family of models. Even you will be surprised that partly only both eViews and Stata can help. And I'll show you once I start the discussion. I just this year on the January, February also we did some study of volatility spillover effect from spot market to futures market. We have index futures, we have got index. So index, we have index future, and similarly we have got options. So study was on how the on this. Suppose we say y1, we say y2, and we say y3. Then the study was very simple that on the volatility of y1, how y2 we only went for bivariate. So y2 is impacting on y3, and similarly how y3, the y1 and y2. I mean that way we did the study that how the volatility of one is getting impacted by other. And we explored whether there is any volatility spillover effect or not due to other market. This study becomes much more meaningful because we quite often say that because of futures market, especially in commodity, the spot market is spoiling. So we would like to know whether the volatility which is present here is going to adversely impact the volatility of a spot market. So that study was meaningful from that point of view. So when we went there to study, we found that again eViews and Stata were not compatible. So we used RATS. RATS is another name of a software, is the name of another software, RATS. RAT and SRATS. Same RATS. So this software was of use. So point here I'm trying to highlight is as we are advancing, the computing skills of softwares are also helping us more. The ideas were there the science or methodology was there, but computational limitations were there, which we are, with every passing year or days or months, we are trying to overcome them. So I'll discuss with you some restricted form of a bivariate Gauge model. With this very reason, neither Stata or eViews support that fully. Partly it is supported. So whatever best we can estimate with the help of eViews and Stata, we'll be doing it. And right now, I don't expect you to learn RATS and do it. It is slightly time consuming. So there's no point of forcing you to go and learn RATS and practically do what we have done. So what I'm expecting that first of all, we'll understand the concept of bivariate and multivariate, and then we'll go for estimating some simpler examples of bivariate Gauge models, and we'll try to find out how to perform our assignment also. So that is the purpose of discussion. We'll confine ourselves to this much only. Yeah. Anyone? Anything? Great. What I'm going to discuss, please pay attention, because I know that it is recorded, available to you. So you can all the way get back to it again. So if you're not listening to me, then you have to do it. You will surely, I'll not use it. I have more cleaner data, so I'll use that so that we are not held up. When we discuss, we don't want to held up. So I have cleaned the data, so I'll be using this data, same data we are using. As such, I'm not going to do anything big. We'll use the prices directly. I'll give you some idea how you can do it. So 2703 is the number of observations. I'm just copy pasting BSc in Singapore prices. 2703. So we will open one new work file, undated, unstructured, 2703, and we have got quick, empty group. First was BSc, other was Singapore. We'll change the name BSc, and this was Singapore. So here we have got data is ready. So right. So please pay attention. The style of estimation will be slightly different. It will not be usual format in eViews. As I told you, that estimation of bivariate or multivariate Gauge is slightly different, and though only many advances have taken place even in Stata and eViews, but still the full facility or to estimate bivariate or multivariate Gauge is still not available in these two softwares. So whatever they have, that has to be, the best is you go for object. Yeah, new object, will create new object. And when we open this, I repeat, object, new object. When you open, you will have something like that. Anything can be created, we'll create one system. So we can go for OK. So something like that will be there. And there you have to write the specification. So write the specification. I'll suggest that this is the idea. I'm just intentionally showing you what you should write there. So what happened? We have got a series. So Y we have got. So YT we have. So if we take log of YT divided by YT minus 1, what will be this? Yes, what will be this? Return series. So it will be as good as when we said that return is ln P2 by P1. Same thing I'm writing. So this is there, first thing. So this can also be written as d log yt. It means this notation would be read as log yt minus log t minus 1. Difference is open. So this is also nothing but log yt by yt minus 1. So instead of writing this, what is recommended in eViews to enter this? So right now, what facility partly when we are running this or writing this way, we are getting is that we are not converting the price series to return series. Rather, we are straight away making use of the functions available in eViews and going to have same estimation the way we did earlier of a return series. So we are not running the price, still we are converting that into return, but we are doing it straight away with the help of commands in eViews. So log in eViews is nothing but natural log. So you will write one, and you give, this is the standard way to give any coefficient in eViews. So same thing we are doing, and we'll be showing you only two as I have taken BSc in Singapore, two Y1 and Y2. So Y1 I'm taking BSc and Y2 I'm taking as Singapore. And here I'll write C2, that's it. So practically when you open the system through object system as the object, then these are the specification which you need to enter in the system. I hope the point is clear.
Yes, sir.
So here I'm just going to write d log, and I have got BSc is equal to C1. Enter d log, I hope it is visible, d log Singapore is equal to C2. And I won't do anything, only I have written this much, and I'll go for estimate. So when I click the estimate, please remember what I'm doing. I could have opened this much through other channels also. I've tried to give you one sequence. I've gone to object, new object, systems. This dialog box came. I wrote my specification of my equations, and then I have gone for estimate. When I'm going for estimate, let me be very clear what exactly we are estimating. So we should not cram, just understand what we are doing. So we are right now with the help of bivariate model, bivariate. In bivariate, what we are saying that BSc and Singapore, these two indices, Sensex, Singapore Index, Singapore Stock Exchange, their index name I don't remember. So the values of those these two time indices are with us, and we are trying to run one bivariate model. And as I open it, you'll have more clarity. Estimate, as I said. So when I have to estimate, I'll go for arch. So within system estimation, I have to give the arch option. So estimation method arch. So you'll find that this window will come. So I'll show you one by one. And if you're not listening, obviously you look at the video, whatever you have to do, but you have to be specific. These are the methods. Look at what is, this is estimation method we have selected. Then we have got this which model. There are three possible models available in GART in this eViews, so we can't have fourth. And autoregressive order, we are intentionally keeping 1 and 1 so that the number of parameters still remain as less as possible. By the time we have 2 or 3, you'll find that the number of parameters will increase in that proportion, which we are strongly discouraging for the practical purpose. So look at, these are three. First is diagonal VEC. There are two popular bivariate Gauss family of models, VEC and BEC, VECH and BEK, BEC, VEC and BEC. Diagonal are estimated so that the assumptions are there, so that number of parameters go down considerably. That's why diagonal estimations. And in middle of that, you are finding constant conditional correlation, CCC also it is known. They have their own pluses and minus, and very simple rule. Suppose you estimate the same model using all three, and then you look at in all the three cases what are the AIC values, and the model which has got the least AIC value can be shortlisted. So that can be all the time done. We'll be using diagonal vec. That same thing I have given you as assignment. So this is the model type. We'll stick to diagonal vec model. Diagonal vec gauge model. Vec gauge is not written. So specification is if I write it, what I'm practically estimating right now. So diagonal vec is written CH and gauge, vec gauge. And the specification is, you can write down D vec, and specification is 1 1, as you're finding diagonal vec 1 1. So just because we are putting both the terms, and you should not forget that arch term was for response, and gauge term was for persistence. So that basic idea still remains there. I'll give you a little more as I open it, as you get the output. I'll give you one or two more things. So this is, I hope we are together. You are listening to, understanding, or I'm just giving one way, discussion. First of all, this
Listening,
is
sir.
only two guys are in. So this is in itself slightly heavy. But if you talk to me, then probably it will be, I will be confident you are getting it. Okay, I have no choice. So here we have got model type. As I said, that diagonal vec, CCC, or diagonal vec. These are three possibilities. We are sticking to diagonal vec. And here what is happening, arch coefficient restrictions. I'm saying that restrictions are essentially important, so that whatever you estimate, that is understandable, or you can easily grasp the meaning, or EViews can compute. So keeping that thing in mind, there are three possible constants, obviously. I mean, three possible coefficients are there. Constant, as I've told you. Though we are talking about bivariate, but these three things will remain there. We have constant, we have constant this, and we have the arch terms, alphas. We will have gauge terms, betas. So these three type of terms are going to be in different combination, depends upon the method which we are going to select, which bivariate or multivariate gauge model method we are selecting. Accordingly, the options of constant, arch terms, and gauge terms will vary. But all these three, whatever we have discussed in univariate gauge, will remain there. That will not change. So we are keeping things simple, and we are trying to understand diagonal vec gauge model and constant. And then here you will find restrictions. All these things can be taken. Constant can be any of these three. So best and most sought after is that you take an infinite matrix, so that the values are in symmetry. But as we change it, you won't find that every time infinite matrix is an option. I'll show to you right now. First, let me complete. A gauge one can also be any of these, but stick to infinite matrix. And gauge one can also be any of this, but stick to infinite matrix. So that is the default setting, and that is the sought after setting also. But as let's say I go for conditional constant conditional correlation, and if you look at here, it is giving you some option. Number of options are less. Arch term number of options are not there. It is not highlighted even. Gauge is also not there. Suppose I leave this constant conditional correlation issue and move to diagonal vec. You'll again find that options are here. Slight options are there, but as you go for here also, you're finding some diagonal vec. Constant are there, but arch and gauge terms are not having any option. So constant will have, but constant have full range, but neither arch does not have any options, not highlighted similarly. So That endorses my point when I said that despite the fact that a lot of advancement would have taken place in software to compute by our multivariate Gauss family of models, still there's a lot of scope. They have many more methods to introduce. They have to add many other features. But it's a too specialized. People go for either RADS, or when they go for open source means they can go for R. R also help. It's open source, slightly difficult, but it works. And but we have used RADS and we have found that RADS is wonderful, but it's a paid software. It's not open source. So BEC-GARCH is having lesser number of options. So as I was saying, that restrictions are there. We'll stick to diagonal VEC. We are estimating diagonal VEC, which is having all the options. So as I show you the output, because writing right now the expression will be too tedious. So I'll show you from the output, which will be generated by bivariate VEC, diagonal VEC model. Bivariate because we have taken two, only BSc and Singapore. I could have taken third. Number of parameters will go up accordingly. We are not, it's not relevant also for us. What we are trying to understand that we will be able to calculate the co-movement of volatility between these two time series. So that we are going to have the study, and we'll be able to make statement that what is the co-movement or co-variance tendencies between BSE stock exchange and Singapore stock exchange. That we'll be able to estimate. So options, we let all the this we can change, and rest of the settings we can leave as it is. If you have anything to ask, please ask. Else I'll go for OK. And I have gone for OK, and here you get the output. Output are slightly difficult to read. So suggestion is that you scroll it down and look for transformed variance coefficient. This is very easy to understand. Look here, if you look at these are in finite matrices. So don't worry what they are representing. Just worry whether they are scalars or infinite matrices, because the values are same. Look at 2.87 10 to the raised power minus 6. You'll find same thing is here. So both the values are same. So need not worry, because we have already taken matrices restriction. So it will be same. What here, the important thing here is that we should know what we are looking at. So M is constant. You can note it. M means constant. So when I said that omega I made, so M represents constant. M is constant. And you are getting A's. And you note 1, 1. 1, 1 means 2, 2 for second. I'll show you the specification. Specification something like that. I'll show you specification something like that. I'll go for view and representation. Let me complete this discussion first. So we have got A1, A's are alpha. A's are alpha, and you have got B's. So all the B's are nothing but beta. This much we have to have the clarity, and obviously when we are having 1, 2 or 2, 3 something, it is very obvious that what does it represent. And we'll have better clarity as we move to representation. I mean, we'll look at the expression, and then we'll find out that which expression talks about what. So I repeat, we have to scroll it down, look at the transformed variance coefficient, so that we can make some interpretation, because these are very abstruse. We do not know. I mean, esoteric to understand. It's very difficult to figure out what they're representing. But these are easy to understand. And as I've given you this clarity, that M stands for constant, A stand for alpha, B stand for beta. So again, let me show you the representation expressions. So we'll go for representation. Here we go. Within this also you go for variance and covariance equations. These are more meaningful and user friendly. So as you look at here, I don't know whether I can increase the size. Yeah, I can. Look at here. Look at only the highlighted portion. And highlighted portions are having three expressions. And please pay attention what they are representing. If I have to explain, they are representing one is sigma 1, sigma 2, and then third is sigma 1, 2 square. So this they are saying covariance. And these are usual Gauss terms. Covariance between 1 and 2. So they are great. They will tell you some stories. I'm not saying anything. These two, they are still the individual discussions, how the conditional variance of one is going to be impacted. So then you have to look at the value of alpha. This is A11 and B11. They will tell you what they used to represent when we talked about univariate. So interpretations are going to be same. Beta 111 will talk about persistence. A111 will talk about the responding tendencies. How much reactive or responsive the Garch1 here represents the first item which you have entered, first expression, that was BSc. So Gauge1 for BSc, Gauge2 for Singapore, because it was second. And 1 2 means here, just because we do not have 1 2 or 2 1, means the effect of 1 on 2 and effect of 2 on 1. So just because we are using diagonal, so assumptions are there that 1 and 2 and 2 on 1 both are same. Diagonal Wick Gauge model we are estimated. If we have estimated only, I'll show you the results of simple BEC 1-1 model. So there, when we run BEC 1-1 model, then you have the facility of 1, 2, and 2, 1. So there, the story becomes much more clearer in terms of volatility spillover from 1 to 2. I mean, from one variable to another variable. So that we cannot estimate in neither in Stata nor in EViews. So whatever best we could have, we can estimate using these two software. We are doing it because R is again very time consuming, so it's not advisable at this juncture, and similarly RATS is also not advisable. So we'll use it. I'll show you the results of RATS. Just wait. Last year, I mean this year only, I've got one good study published. I'll show you that results. Just wait. So right now, if I talked about the variance of 1, variance of 2, and this is covariance. So when I say spillover exactly we can't estimate unless until we have got Beck Garch 1-1 estimations. So at the most, what we can do, if you look at here, this covariance expression is of meaning to us now. When we want to talk about how both of them are, having mutual association, and not for price, not for return, but for volatility. Please, you have to be very specific that this discussion is exclusively meant for volatility. When we are having covariance, so we are not talking about covariance in the return series. No, we are talking about covariance in the volatility. So A112 will give you some sort of responsive tendencies and between 1 and 2. So 1 and 2 together. It's not 2 into 1 or 1 lead to 2 or 2 lead to 1. No, it's not like 1, 2. So mutual responsive tendencies can be estimated, but this does not give you much input. Rather, this B is nothing but the persistence. So the significance of this term and the value of this term will give you idea whether the co-movement of volatility of both the series are strong, are there or not, and if it is there, then whether they are strong or weak. So right now in BEC 1-1, you will find that you will have B1, 2-1 also. So how 1 is impacting 2 and then how 2 is impacting 1. So that is also possible in BEC 1-1 estimation. But right now we are just getting to know what is the covariance. So both order is immaterial, both together, what is the covariance tendency. So that is estimated with the help of beta B112. So I hope this point is clear that I have shown you these three, and if I show you this is the output, these three expressions, and same these three things are there as I have talked about. I'm unable to increase the size here. So same thing as both cannot open together. So the way we were talking here. So just look at what we are looking for. So when we want to talk about covariance or coefficient of covariance of volatility, then we are looking for B112. So we will go to B112 and we look at, we scroll it down, B112. So look at this term. And what we are finding that this B112 term is having a value of 0.5. It's having a value of 0.5. I'm not look at whether it is significant or not. Yes, it is having a value of p-value of less than 0.05. It is having a value of 0.01. So we'll say yes. The impact, the co-movement impact between Singapore and BSE is significant, and that to tune of 0.5. That is interpretation. So in the assignment, if I just try to correlate this work with the assignment, I'll show you one more. But let me complete the discussion. Then you have to show whether the co-movement of BSE, Sensex with your stock, or if you happen to take Dow Jones, I'll recommend that you take Dow Jones for the similar dates, and then you find out the diagonal Wick-Garch model and look at this term, beta term, this covariance term, and if it is significant, so it means the co-movement in volatility is there. So if the change in volatility will take place in one, then that will have the degree of association is 0.5. So when you have two, then you can compare the higher the degree, higher the value of coefficient will be more a stronger covariance. So this is the discussion. I'll change the values and we'll have slightly more discussion. We'll have at least one more values to discuss. Any question?
Sir, one of the values is insignificant. What does that mean? The
Yeah,
p-value.
P-value of we have like this, huh? This A12. So A12, if I understand, this is the alpha value of covariance term. So we'll say that short term, just let me look at the output. I went to this term. So this term is insignificant. It means this term is insignificant. So we'll say that this is the covariance short term. So the responsive tendencies of covariance term of volatility is not significant. That is a simple interpretation.
Okay,
Yes.
sir. Okay, sir.
Because alphas represent responsiveness and betas represent the persistence. And alphas, if I get anything different, I'll share with you. You are Tanay? Tanay or Shivardhan? Shivardhan.
Srivardhan, sir.
If I get anything else, I'll share with you. But to the extent I'm understanding, nothing else. Alpha still represents the responsiveness. But I'll find out. I'll try to find out. If I get something, I'll share with you. No problem. Anything else? Only student of 26 students, 2 active, 24 inactive. Great. I'll quickly show you with the help of other time series also. At least I'll use Taiwan. I'll add that. Close that system. I'll delete. I'll have one more. So A1 and then close it. So we have got 3. Now I can open it, but I'll go for that new object system. Okay. And here I'll again go for log, D log difference, D log BSC is equal to 7. I'm still sticking to bivariate, not going for multivariate or 3. D log Taiwan, I hope I have written the same spelling, C, and I'll go for estimate, and there I'll go for arch, still going for diagonal option, customary change, and everything, all the settings, all three are finding infinite matrices are there. And here I go for estimation. And I'll look for beta 1, 2, you can look. And this, as you are finding this, I can again check beta 1, 2 is nothing but the this. So beta 1, 2 is the meaningful term for understanding the co-movement of both the co-movement of volatility of both the time series. And we'll also check, Shivadan was saying that it was the previous case, weird insignificant, I don't know. So A 1, 2, it is significant here, but negative. So again, with the normal discussion that it is not following the stability conditions, so this may be ignored. But this term which we are looking at, it is very high coefficient and it is very high significant. So beta 1, 2 is very highly significant. We'll say that the co-movement in volatility of BSE and Taiwan is very strong. So with this, we have come to an end to volatility models. I know you are already bogged down with so much work of other courses you should definitely do as per your priority. But I'll say that it was very interesting discussions on GARCH or volatility. And you'll come across many occasions to discuss GARCH. We have discussed univariate and bivariate. Bivariate discussions you won't get that easy. This is slightly tacit information which are not available so easily. So I have to really slog. Only a few years back I understood in learning something new, which I wanted to show you one result of that GARCH. Yeah, here I'm quite happy. So one BTech student, he was doing his internship with us, Anish, and he has done it. So he capabilities wise, that's why he said that your background, some material interest matters. So look at the output. I'll straight away show you the output. Beck 1-1. The output which I'm going to show you is of Beck 1-1 spot and future. Look at here, spot and future. And as you are finding, same. These are C's are meant for this interpretation is taken from RATs. So C is constant, A is alphas, and B are betas. So look at beta 1, 2, and 2, 1. So 1, 2 means how spot is impacting the volatility of a spot is impacting the volatility of futures. And when I say beta B2, 1, it means how futures volatility is impacting the spot. And as you are finding, both are significant. T starts are written in the beginning. This is so these I can generate if I have got Beck, as you are finding Beck 1-1. We have just run Beck 1-1, and these are the outputs. But I can't because here if I just want to estimate, then my limitation is that I can only go for diagonal Beck, which will give me much more inferior description as compared to when diagonal Beck. So I stick to diagonal Beck. I didn't go for diagonal Beck. So these are the limitations, as I have in the very beginning. I have told you, RATS was handy and helpful for us. So this was a good study, as I was talking. It was a volatility spillover effect in spot futures and options market, how one market's volatility was impacting the other. Good discussion, very informative discussion on that. So enough for the day. So all the best for your assignments. I hope that you will be able to use these videos and your batchmates, and otherwise both of you will be taking the lead to help your school, help your batchmates. So please do it. And now we are going to start next session. We have 2 more weeks, 3 weeks practically, but I'll take 1 session per week. So right now I need to have 16 sessions. With this I have finished 14, so I'm left with 2 sessions of 1.5 hours each. So practically I have to discuss 3 hours only, and I'll be talking about panel data. So I know you guys are already preoccupied, but that's again very tacit information, tacit knowledge, and very good to have the understanding about panel data. So I'll suggest that you guys spare time and go through it. From the examination point of view, you might not have any concerns, but whenever you have to do anything empirical, then so far we have talked about cross-sectional, we have talked about time series. Now we are going to have a combination of these two, which we call panel data. So in terms of ability to reflect the information, this panel data are great. They are wonderful, and they can provide many more information which their cross-sectional or time series counterparts are unable to do. So from that point of view, panel data are very strong, and for last couple of years I'm exploring panel data only. So it's quite favorite thing for me, and I'll discuss. Yeah, somebody was trying to say something. Right, so we are closing. Thank you very much. We'll meet again next week, and I hope that you will be able to finish your assignment successfully by 11th. Within 2-3 days, you will get your marks also.